December 17th, 1944. Houffalize, Belgium. The morning fog clung to the Ardennes Forest as Oberleutnant Ernst Richter watched through his Panther's cupola periscope. His tank sat hull down behind a snow-covered embankment, engine idling quietly, waiting for the American column that intelligence had reported moving up the narrow forest road. Richter had commanded Panzers since Kursk. He understood tank warfare intimately. Fire first, fire accurately, maintain distance. Let the superior German gun and armor work as intended. The Panther's 75mm KWK-42 could penetrate a Sherman's frontal armor at 2,000 meters. The Sherman's 75mm M3 could barely scratch a Panther frontally even at point-blank range. The mathematics of armored combat favored Germany decisively in any conventional engagement. What Richter witnessed over the next 7 minutes would shatter every assumption he held about American tank tactics. The realization came not as theoretical, understanding, but as physical violence that left his Panther crippled and his crew scrambling for survival. By the time the Battle of the Bulge ended 6 weeks later, German Panzer commanders across the Ardennes would report the same disturbing pattern. American Sherman crews had stopped fighting by the rules. The Americans called it close assault tactics. German after-action reports used blunter language, ramming attacks, collision tactics, suicidal charges. But there was nothing suicidal about what the Americans were doing. They had discovered that against superior German armor, conventional gunnery wasn't the only option. Sometimes the 30-ton Sherman itself was the weapon. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The sound reached Richter first. Not the sharp crack of tank guns, but the deep mechanical roar of engines pushed to maximum RPM. Through the fog, shapes materialized. 5 Sherman tanks moving at full speed directly up the road. No tactical dispersion, no hull-down positions, no careful advance with overwatching elements, just speed and aggression that made no tactical sense. Richter's gunner, Unteroffizier Hans Müller, acquired the lead Sherman immediately. Target, tank, 1,200 meters. Fire when ready. The Panther's gun fired. The 75mm armor-piercing round crossed the distance in under 2 seconds and struck the lead Sherman's glacis plate. The shell penetrated, and the Sherman erupted in flames. Its crew bailed out as the ammunition began cooking off. 4 Shermans remained. They didn't stop. They didn't seek cover. They accelerated. Müller traversed to the second Sherman. Target, tank, 1,000 meters. Fire. Another hit. Another penetration. The second Sherman slewed sideways, track blown, blocking half the narrow road. Its turret traversed desperately, trying to bring its gun to bear before the crew abandoned the vehicle. 3 Shermans remained. They were now less than 800 meters away and still accelerating. Richter felt the first stirring of unease. This wasn't how Americans fought. They advanced cautiously, using their numerical advantage carefully, accepting casualties but never courting them unnecessarily. Müller's voice rose slightly. Target, tank, 700 meters. Fire. The third Sherman took the hit on its right track. The tank spun violently but didn't stop. Its driver corrected, and somehow the damaged tank continued forward on its remaining track and road wheels, grinding metal, screaming, moving at perhaps 15 kilometers per hour. 2 undamaged Shermans remained. They were now 600 meters away, 500, 400. They're not stopping, Müller said, his professional calm cracking. Why aren't they stopping? Richter understood suddenly and completely. Driver, reverse, full speed. The Panther's driver, sensing his commander's urgency, slammed the transmission into reverse. The tank lurched backward. But the Panther, for all its advantages, was not designed for rapid reverse movement. It managed perhaps 10 kilometers per hour in reverse, half the speed the Shermans were achieving in forward gear. Müller fired again at 300 meters. The shot struck a Sherman's turret, ricocheted upward without penetrating. The Sherman's own gun fired a desperation shot that went wide. But the Sherman didn't slow. Its driver held his course, engine roaring, tracks throwing snow and mud. 200 meters. Brace for impact, Richter shouted. The lead Sherman struck the Panther's left side at approximately 35 kilometers per hour. 30 tons of American steel and machinery, driven by a 400-horsepower radial engine, transferred its kinetic energy into the Panther's side armor in a fraction of a second. The collision sound was tremendous. Metal screamed, welds parted, armor, plate buckled. The Panther, weighing 45 tons, was shoved sideways despite its mass. Inside, Richter was thrown against his cupola hard enough to see stars. Muller crashed into the gun breech. The loader collapsed into the turret basket. The driver's head snapped forward into the periscope. The Sherman's driver had aimed perfectly. The impact point was directly over the Panther's drive sprocket and final drive, the weakest point in any tank's running gear. The final drive, already stressed by the Panther's chronic mechanical problems, shattered completely. The drive sprocket bent. The track derailed and wrapped around the road wheels. The Panther was immobilized. The Sherman, its frontal armor crumpled, engine smoking, backed away from the impact. Its turret traversed. At 15 meters range, the Sherman's 75mm gun couldn't miss and didn't need to penetrate the Panther's frontal armor. The American gunner aimed at the thinner side armor, now exposed by the collision. The Sherman fired. The shell penetrated the Panther's side armor and detonated inside the fighting compartment. Richter, still dazed from the impact, felt the flash of heat and pressure. "Bail out!" His crew needed no encouragement. They abandoned the Panther through every available hatch, dropping into the snow as the internal fire spread. Richter was last out, pulling himself through the cupola as ammunition began exploding inside his tank. He stumbled away from the burning Panther and looked back at the carnage. 2 Shermans destroyed by his gun, 1 Sherman damaged but still mobile, 1 Sherman that had rammed his tank, its front end crumpled but crew already working to restart the stalled engine. 1 more Sherman maneuvering to finish off the damaged vehicle that had lost its track earlier. 5 American tanks engaged 1 German Panther. The Americans lost 2 tanks, destroyed, 1 heavily damaged. The Germans lost 1 Panther destroyed, crew survived. By conventional kill ratio calculations, the Germans had won the engagement, but Richter's Panther would never fight again. The American tanks, even the damaged ones, could potentially be recovered and repaired. The 2 destroyed Shermans would be replaced within days from American production that seemed unlimited. His Panther, a precision-engineered machine that had taken months to build, was scrap metal. Most troublingly, the Americans had achieved their objective. They'd destroyed his tank and cleared the road. They'd done it by accepting casualties that German doctrine considered unacceptable, using tactics that German training considered insane. They'd done it by ramming. The ramming tactic that Richter experienced on December 17th wasn't improvised desperation. It was the culmination of 2 years of American tank crews learning hard lessons about fighting German armor with inferior equipment. The problem had been evident since the first Sherman versus Panther engagements in Normandy during summer 1944. The Sherman's 75mm M3 gun could not reliably penetrate a Panther's frontal armor at any range. The Panther's 75mm KBUK-42 could destroy a Sherman frontally at ranges exceeding 2,000 meters. In a conventional gunnery duel at medium to long range, the Panther won every time. American tank crews died learning this lesson. The 2nd Armored Division lost 67 Shermans in the first week of fighting in Normandy. The 3rd Armored Division lost 91 tanks in 10 days. Crew casualties were devastating. Replacement crews arrived, climbed into replacement tanks, and died in turn. The survivors developed tactics born from necessity. If you couldn't penetrate German armor at range, you closed the distance. If closing the distance exposed you to German fire, you moved fast enough that German gunners couldn't track you effectively. If you reached point-blank range and still couldn't penetrate frontally, you used the Sherman itself as a battering ram to disable the German tank's running gear, then fired at the thinner side or rear armor. The tactic required courage bordering on madness. It accepted casualties that made conventional officers uncomfortable. But it worked. And as word spread through American armored units, more crews adopted variations of the close assault approach. Lieutenant Colonel James Burt of the 66th Armoured Regiment pioneered systematic ramming tactics in October 1944 during fighting around Aachen. Burt had lost too many tanks to long-range German fire. He gathered his surviving tank commanders and explained a new approach. "The Panther is superior to us in every conventional metric," Burt told them. "Better armour, better gun, better optics. In a fair fight, they win. So we don't fight fair. We fight close. We fight fast. We use our advantages, numbers, reliability, and the fact that we can replace our losses while they cannot." Burt's tactical innovation was recognizing that the Sherman had advantages that conventional doctrine overlooked. The Sherman was mechanically reliable. It could move quickly and maneuver aggressively without breaking down. Its suspension handled high-speed cross-country movement better than German designs. Its reverse speed was excellent, allowing rapid withdrawal if needed. Most importantly, American logistics could replace destroyed Shermans faster than German factories could build Panthers. This meant American commanders could trade tanks at ratios that would bankrupt German Panzer divisions. Burt's unit began practicing close assault tactics. Shermans would advance in groups of 4 or 5, moving at maximum speed. German tanks would typically destroy 1 or 2 attackers, but the remaining Shermans would close to point-blank range before German gunners could reload and fire again. At ranges under 100 meters, the Sherman's gun could penetrate Panther side armor. At ranges under 50 meters, ramming became viable. The first documented successful ramming occurred on October 14, 1944, near Übach, Germany. Sergeant Robert Miller's Sherman encountered a Panther hull down behind rubble. Miller couldn't maneuver for a side shot. His 75mm gun couldn't penetrate frontally. German infantry with Panzerfausts were closing from the flanks. Miller ordered his driver forward at full speed. The Sherman accelerated directly at the Panther. The German crew, seeing the American tank charging rather than withdrawing, hesitated for critical seconds, unable to believe what they were witnessing. Miller's Sherman struck the Panther's left track at 30 km per hour. The impact derailed the Panther's track and damaged its drive sprocket. Miller's gunner immediately fired at the now exposed side armor from less than 10 meters. The shell penetrated and disabled the Panther. Miller's Sherman suffered a crumpled bow plate and damaged transmission, but the tank remained mobile enough to withdraw. The Panther was completely immobilized and subsequently abandoned by its crew. Word of Miller's success spread rapidly through American armored units. Tank crews facing impossible tactical situations began attempting similar maneuvers. Not all succeeded. Shermans that rammed German tanks often suffered severe damage. Crews were injured by the violent impacts. Some rammed tanks were immediately destroyed by point-blank German fire. But enough succeeded that the tactic became increasingly common during autumn and winter fighting in 1944. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The mathematical advantage of ramming tactics became clear when American intelligence officers analyzed combat results from October through December 1944. The data was striking and initially counterintuitive. In conventional long-range engagements, American Shermans destroyed German Panthers at ratios of approximately 4 Shermans lost for every Panther destroyed. Unsustainable for any force with limited replacement capacity, but acceptable for Americans whose factories produced Shermans in thousands. In close-range engagements under 200 meters, the ratio improved to approximately 2 Shermans lost per Panther destroyed. Better, but still costly. In engagements where ramming tactics were employed, the ratio shifted dramatically, approximately 1.3 Shermans lost per Panther destroyed. This represented a roughly 3-fold improvement in effectiveness compared to long-range gunnery duels. The reason was simple: physics, combined with tactical psychology. A Sherman, charging at full speed, crossed the danger zone of German gun range in seconds rather than minutes. German gunners, trained for precision long-range shooting, struggled to engage rapidly moving targets at close range. The psychological impact of a 30-ton tank charging directly at you affected German crew performance measurably. Most importantly, ramming disabled German tanks even when American guns couldn't penetrate. A Panther with destroyed running gear was effectively killed regardless of whether its armor was penetrated. German recovery and repair capabilities, already strained by mechanical breakdown rates and Allied air superiority, couldn't keep pace with tanks disabled by ramming. The tactic's effectiveness increased when employed by multiple Shermans simultaneously. German tanks could engage one, maybe two, attacking Shermans before the others closed to ramming range. This meant attacking groups of 4 or 5 Shermans could almost guarantee at least 2 would reach ramming range, even if the others were destroyed. American tank doctrine evolved to incorporate these realities. The 3rd Armored Division issued tactical guidance in November 1944 that explicitly included ramming as an acceptable, close assault technique. The guidance noted, "When facing superior German armor, in situations where maneuver is impossible and withdrawal impractical, aggressive, close assault, including deliberate collision with enemy vehicles, may achieve mission success at lower overall casualties than conventional engagement." German intelligence officers noticed the pattern by late November. After-action reports from Panzer units across the Western Front described American willingness to sacrifice individual tanks to disable German armor through ramming. German tactical guidance was updated to warn crews about the tactic and recommend maintaining distance from American formations. But maintaining distance required space to maneuver. In the close terrain of the Ardennes, the bocage country of France, and the urban fighting in German cities, space was exactly what German tanks lacked. The Panther's superior long-range gun was useless in village streets, where engagement ranges measured in tens of meters rather than thousands. The Battle of the Bulge in December 1944 demonstrated ramming tactics on a larger scale. German forces committed their last significant armor reserves to a surprise offensive through the Ardennes. American units, caught initially off balance, fell back fighting. Tank engagements occurred at close range in forest roads and village streets, where German range advantages meant nothing. At Bastogne, surrounded American tank crews used ramming tactics repeatedly during desperate defensive fighting. Captain James Leach of the 10th Armored Division recorded 5 separate ramming incidents in his unit's sector during one day of fighting on December 22nd. In each case, Sherman crews deliberately rammed German tanks that they couldn't otherwise defeat, accepting damage to their own vehicles to disable enemy armor. The results were documented carefully. 15 German tanks destroyed or disabled in Leach's sector. 8 American Shermans destroyed. 7 American Shermans damaged but recoverable. The ratio, approximately 1.9 American tanks lost per German tank destroyed, significantly better than conventional engagement ratios. German commanders found the American willingness to trade tanks deeply frustrating. Oberleutnant Wilhelm von Schell, commanding a Panzer battalion in the Bulge, wrote in his after-action report, "American tank crews show reckless disregard for their own safety. They charge our positions at full speed, accepting casualties that would be unthinkable for German forces. Individual German tanks achieve superior kill ratios, but American replacement capacity means they can sustain losses we cannot." The psychological impact on German tank crews was significant and demoralizing. Panzer crews had been trained to rely on their technical superiority. German propaganda emphasized quality over quantity. The Panther was superior to the Sherman in every measurable specification, but specifications meant nothing when 5 Shermans charged your position simultaneously, and at least 2 would reach ramming range, regardless of how accurately you shot. The knowledge that American crews would deliberately ram your tank if they couldn't penetrate it changed tactical psychology profoundly. German crews became hesitant in close terrain, knowing their range advantage was negated. They withdrew from positions they might have held, unwilling to risk being trapped in close combat, where ramming became viable. The confidence that had characterized early Panzer operations disappeared, replaced by caution born from respect for American aggression. The mechanical consequences of ramming were severe for both sides. Shermans that rammed German tanks suffered predictable damage patterns. Frontal armor plates buckled or cracked from the impact. Transmissions were stressed beyond design limits by the sudden shock load. Suspension components broke, engine mounts fractured, tracks derailed. Approximately 40% of Shermans that successfully rammed enemy tanks were immediately immobilized and subsequently destroyed. Another 30% suffered damage that required depot-level repairs. Only 30% remained mobile enough to withdraw under their own power. But German tanks that were rammed suffered equally severe damage. Final drives shattered from lateral impacts. Drive sprockets bent or broke. Tracks derailed and fouled. Suspension components failed. The Panther's chronic mechanical weaknesses made it particularly vulnerable to ramming. The final drive, already prone to failure under normal operation, was completely unable to withstand ramming impacts. Approximately 70% of German tanks that were rammed became immediately immobilized. The remaining 30% suffered damage that, combined with Germany's deteriorating logistics, effectively removed them from combat operations permanently. The replacement differential made ramming sustainable for Americans, but catastrophic for Germans. A damaged Sherman could be replaced within 72 hours from depots that maintained thousands of replacement vehicles. American tank recovery units operated efficiently, pulling damaged tanks back to repair facilities where standardized parts and procedures enabled rapid restoration to service. German tank replacement was impossible by late 1944. Panthers destroyed or damaged in the Bulge could not be replaced. German factories were producing fewer than 200 Panthers per month, barely enough to replace normal attrition. Tanks disabled by ramming simply disappeared from German order of battle permanently. The arithmetic was brutal and undeniable. If American crews could trade 1.3 Shermans for every Panther destroyed through ramming tactics, and if American factories could replace those 1.3 Shermans within days, while German Panthers could never be replaced, the strategic calculation favored aggressive tactics regardless of immediate tactical costs. American commanders recognized this arithmetic explicitly. General Maurice Rose, commanding the 3rd Armored Division, issued guidance in January 1945 that acknowledged ramming as standard doctrine. When facing heavy German armor, use speed and numbers. Close rapidly from multiple directions. Accept casualties to achieve close range. Ram if necessary. We can replace our losses. They cannot. The human cost of ramming tactics was significant and deserves acknowledgement. Tank crews who deliberately rammed enemy vehicles faced terrifying violence. The impact threw crew members against interior surfaces with bone-breaking force. Injuries were common: concussions, broken bones, internal bleeding. Some crew members were killed by the impact itself before enemy fire could reach them. But tank crews accepted these risks because the alternative fighting German heavy armor, conventionally at long range, produced higher casualties. American tankers calculated their survival odds carefully. Closing rapidly and ramming gave you perhaps a 60% chance of surviving the engagement. Fighting conventionally at range against a Panther gave you perhaps a 30% chance. The choice was clear to men whose lives depended on tactics that actually worked. Sergeant William Chapman of the 4th Armored Division, who survived 3 ramming attacks during the Bulge, explained it simply years later. We knew ramming was dangerous, but we also knew that sitting at 1,000 meters trying to penetrate a Panther frontally was suicide. At least when you rammed, you had a chance. You hit them hard enough to break their track, your gunner could shoot them in the side, and maybe you all lived. That was better odds than any other option we had. By January 1945, ramming had evolved from desperate improvisation to systematic doctrine. American Armor School began teaching close assault tactics, including ramming to replacement crews. Training emphasized proper target points on German tanks, drive sprockets, return rollers, suspension arms. Crews practiced high-speed maneuvers and learned to brace for impact. The Germans, meanwhile, found no effective counter-tactics. Maintaining distance was impossible in close terrain. Infantry support with Panzerfausts helped but couldn't prevent determined Sherman charges. Mines were effective, but required time to emplace that retreating German forces rarely had. Some German commanders attempted to use the tactic themselves, ordering their tanks to ram American armor. But German tanks were poorly suited to ramming for several reasons. The Panther's final drives couldn't handle the stress. The Tiger was too slow to build momentum effectively. German crews lacked the aggressive training American crews received. Most importantly, German logistics couldn't replace damaged tanks, making ramming suicidal rather than sustainable. The final months of the war demonstrated ramming tactics repeatedly. During the Rhine crossings in March 1945, American armor rammed German tanks, defending the bridgeheads. In the Ruhr pocket, surrounded German tanks were disabled by ramming attacks when ammunition ran low. In the final drives into Germany, ramming became routine whenever German heavy armor appeared in close terrain. The technical analysis of ramming tactics revealed why the Sherman was uniquely suited to this aggressive approach, even though American designers had never intended the tank for such use. The Sherman's structural characteristics, initially criticized as crude compared to German precision engineering, proved advantageous in violent collision scenarios. The Sherman's hull was constructed using a combination of rolled and cast armor sections welded together. This construction method, cheaper and faster than the all-welded German approach, created a hull that was slightly less rigid but more resistant to catastrophic failure under impact. Stress. When a Sherman struck another tank, the welded joints absorbed energy through slight deformation, rather than fracturing completely. German tanks, built to tighter tolerances with more rigid welded construction, suffered worse structural damage from equivalent impacts. The Panther's carefully engineered hull, designed for optimal ballistic protection, lacked the flexibility to absorb ramming impacts without critical joint failures. Welds cracked, armor plates separated, internal components shifted from mountings. The Sherman's suspension system contributed to ramming effectiveness. The vertical volute spring suspension, often dismissed as unsophisticated compared to German torsion bar systems, was actually better suited to violent impacts. The vertical springs compressed dramatically under shock loads, absorbing energy that would otherwise transfer directly to the hull. Each bogie assembly acted as an independent shock absorber, distributing impact forces across the entire track length. The Panther's torsion bar suspension, while providing superior ride quality under normal operation, was less forgiving under ramming impacts. The torsion bars, designed for vertical loads, could not handle the lateral forces generated by collisions. They bent, twisted, or snapped, leaving the tank with broken suspension arms and derailed tracks. The Sherman's transmission, another component often criticized for being overly simple, proved durable under ramming stress. The manual transmission with its robust gearing could handle the shock loads generated when 30 tons of tank suddenly decelerated from 30 km per hour to zero in a fraction of a second. The transmission didn't always survive intact. Many Shermans required transmission replacement after ramming, but it failed gradually rather than catastrophically, often allowing the tank to withdraw under power. The Panther's sophisticated transmission, providing superior performance under normal conditions, was far more fragile. The Maybach transmission used precision gears cut to exacting tolerances. These gears, optimized for smooth power delivery, shattered under sudden shock loads. A rammed Panther's transmission often failed completely and immediately, leaving the tank totally immobilized, even if the running gear remained intact. American tank recovery doctrine evolved to support ramming tactics. By early 1945, American armored divisions maintained dedicated tank recovery units equipped with M32 recovery vehicles, essentially Shermans with the turret removed and heavy lifting equipment installed. These recovery vehicles accompanied frontline units specifically to retrieve damaged tanks immediately after combat. The recovery process was remarkably efficient. A Sherman damaged by ramming could typically be hooked to a recovery vehicle within 20 minutes of the engagement ending. The recovery vehicle would tow the damaged tank to a forward collection point, usually within 5 kilometers of the front line. From there, heavy transporters would carry damaged tanks to rear area depots where repair crews worked around the clock. American maintenance depots operated with industrial efficiency. Damaged Shermans arrived continuously. Specialized teams assessed each tank, categorizing damage and assigning priority. Tanks with repairable damage entered the rebuild process. components were replaced using vast stockpiles of standardized parts. Engines, transmissions, suspensions, even entire turrets could be swapped in hours rather than days. The average repair time for a Sherman damaged by ramming was 48 to 72 hours from battlefield retrieval to return to combat-ready status. This remarkable turnaround meant that a tank damaged on Monday could be fighting again by Thursday. The crews often referred to repaired tanks as zombies, vehicles that had died but returned from the dead to fight again. German tank recovery capabilities, by contrast, had collapsed by late 1944. Recovery vehicles were scarce, transporters lacked fuel, depot facilities were targeted by Allied bombing, spare parts were unavailable, skilled mechanics had been conscripted for infantry duty. A damaged Panther, even one with relatively minor damage, would likely never return to service. This repair differential amplified the effectiveness of ramming tactics dramatically. The real exchange ratio wasn't 1.3 Shermans destroyed per Panther destroyed. It was approximately 0.4 Shermans permanently lost, per Panther permanently lost. The majority of damaged Shermans returned to combat. Essentially, no damaged Panthers did. The tactical evolution of ramming continued throughout early 1945. Tank crews developed increasingly sophisticated variations on the basic technique. The hammer and anvil approach involved one Sherman fixing a German tank's attention frontally, while other Shermans maneuvered for ramming attacks from the flanks. The cascade technique had multiple Shermans charging in sequence, with each successive tank ramming if the previous attacker was destroyed before reaching the target. The most effective variation was the swarm tactic, employed primarily by the 2nd and 3rd Armoured Divisions. 6 to 8 Shermans would advance together at high speed from multiple directions simultaneously. German tanks could destroy perhaps 2 of the attackers before the others closed to ramming range. The surviving Shermans would ram and shoot at point-blank range, overwhelming the German tank through sheer simultaneous violence. Lieutenant Harold Kramer of the 33rd Armoured Regiment described a swarm attack during fighting near Cologne in March 1945. "We had 8 tanks. Intelligence said there were 3 Panthers dug in covering the road junction. We came at them from 3 different streets simultaneously, full speed, no stopping. They killed 2 of our tanks before we reached them. The other 6 of us hit them within seconds of each other, 2 tanks per Panther. The impact sounded like the end of the world. All 3 Panthers were knocked out. 4 of our 6 surviving tanks were damaged but mobile enough to withdraw. We lost 2 tanks permanently. They lost 3 permanently. In a straight gunfight at long range, we'd have probably lost 5 or 6 tanks taking out those 3 Panthers." The psychological documentation of ramming's effects on both sides was extensive. American Army psychiatrists interviewed tank crews throughout the campaign, documenting the mental and emotional impact of aggressive close combat. The findings were counterintuitive and significant. Crews that employed ramming tactics showed lower rates of combat stress reactions than crews that fought conventionally at long range. The psychiatrists theorized that aggressive action provided psychological advantages. When you were charging the enemy at full speed, you felt in control of the situation. You were doing something, taking action, imposing your will. This sense of agency reduced the helplessness that characterized long-range engagements where you were simply targets waiting to be hit. Sergeant Thomas Riley, who participated in 4 ramming attacks, told psychiatrists, "When you're sitting at 1,000 meters, shooting at a Panther that you can't penetrate, you're just waiting to die. You shoot, you miss or bounce off, and you wait for him to kill you. It's terrifying because you're helpless. When you charge, you're scared, but you're doing something. You're in control. You might die, but at least you're fighting, not just dying." German tank crews showed opposite psychological patterns. Panzer soldiers interviewed after capture consistently described feeling helpless against ramming attacks. Their technical superiority meant nothing. Their training emphasized precision gunnery at long range, not brawling at close range. When American tanks charged at full speed from multiple directions, German crews felt overwhelmed and powerless. Oberleutnant Karl Schneider, a Panther driver captured near Remagen, described the psychological impact. You know the Americans are coming. You prepare your position. You have the better tank, better gun, better armor. You should win. Then you see 5 or 6 Shermans charging directly at you at full speed, and suddenly all your advantages mean nothing. You kill 1, maybe 2, and the others keep coming. You know they're going to hit you, break your tank, shoot you from the side, and there's nothing you can do to stop them all. It's like being trampled by a herd of animals. Your skill doesn't matter. Your equipment doesn't matter. You're going to be crushed. The training evolution reflected ramming's acceptance as standard doctrine. By March 1945, American tank schools in England and France explicitly taught ramming techniques. Training courses included impact driving, learning to maintain, control during high-speed approach, aim the tank's bow at the optimal target point, and brace for collision. Drivers practiced high-speed maneuvers on training courses, learning to judge distances and speeds intuitively. Crew coordination, ensuring all crew members braced properly before impact. The driver would announce brace for ram 5 seconds before impact. All crew members would grip structural supports and prepare for violent deceleration. Post-impact engagement. Gunners learned to acquire targets immediately after ramming, firing at side or rear armor from point-blank range before the enemy crew could react. Damage assessment. Commanders learned to quickly evaluate their tank's condition after ramming and decide whether to press the attack or withdraw for repairs. Instructors emphasized that ramming was a deliberate tactical choice, not a desperate last resort. The training manual stated, "Ramming is an aggressive combat technique appropriate when facing superior enemy armor, in close terrain. Properly executed, ramming achieves tactical objectives at acceptable cost. Improperly executed, ramming wastes resources and achieves nothing. Training and discipline distinguish between effective ramming and suicide." The German response to ramming tactics was limited by resources and doctrine. Some Panzer units attempted to develop counter-tactics. These included maintaining maximum distance whenever possible, positioning tanks where multiple escape routes existed, and emphasizing rapid fire to destroy attacking Shermans before they closed to ramming range. German tankers also requested infantry support specifically to counter ramming attacks. Panzerfaust teams positioned near tanks could engage charging Shermans at close range where the shaped charge warheads were most effective. This worked when German infantry was available and properly positioned, but by 1945, German infantry was increasingly scarce and poorly coordinated with armor. Some German commanders considered ordering their own crews to employ ramming tactics against American armor. This was generally rejected as impractical. German tanks lacked the mechanical reliability to sustain the damage ramming inflicted on both parties. German logistics couldn't repair damaged tanks. German production couldn't replace losses. Most fundamentally, German tactical doctrine emphasized preservation of expensive equipment, making aggressive trades unthinkable to commanders trained in traditional warfare. General der Panzertruppe Hasso von Manteuffel, commanding 5th Panzer Army during the Bulge, addressed ramming in his post-war memoirs. American willingness to sacrifice individual tanks to achieve tactical objectives demonstrated a fundamental difference in our approaches to armored warfare. We viewed each tank as a valuable asset to be carefully husbanded. They viewed tanks as expendable tools to be used aggressively and replaced when necessary. In total war against an enemy, with unlimited production capacity, their approach was correct and ours was obsolete. The final statistics from the European campaign validated ramming as tactically sound. American armored divisions recorded approximately 300 documented ramming attacks between October 1944 and May 1945. These attacks destroyed or disabled approximately 230 German tanks permanently. American losses in these engagements totaled approximately 390, Shermans destroyed or heavily damaged. However, of those 390 damaged Shermans, approximately 240 were repaired and returned to service. This meant the real permanent loss ratio was approximately 1.5 American tanks permanently lost per German tank permanently lost through ramming tactics, dramatically better than the 4-to-1 ratio typical of conventional long-range engagements. The ramming tactic's effectiveness increased over time as American crews gained experience and German crews became demoralized. Early ramming attempts in October and November 1944 succeeded approximately 45% of the time. By March and April 1945, success rates exceeded 70%. The improvement reflected better training, refined tactics, and degraded German morale and capabilities. The legacy of ramming tactics extended beyond World War II into post-war tank doctrine and design. American armor schools studied the tactic extensively, documenting lessons learned. The primary lesson was that mechanical reliability and replaceability mattered more than technical superiority in sustained combat. A simple tank that could be produced in thousands and repaired quickly beat a sophisticated tank produced in hundreds that couldn't be maintained. This lesson influenced American tank design for decades. The M26 Pershing, entering service in late 1945, emphasized reliability and maintainability, while improving firepower and protection. The M46, M47, and M48 that followed continued this philosophy. Even the M60 and M1 Abrams, designed generations later, prioritized mechanical reliability and ease of maintenance alongside combat performance. The Soviet military studied American ramming tactics with particular interest. Soviet armor doctrine already emphasized aggressive close assault and acceptance of casualties to achieve objectives. The American experience validated Soviet approaches while providing tactical refinements. Soviet tank training in the 1950s and 60s explicitly included ramming as an acceptable technique when facing superior enemy armor. The psychological dimension of ramming that aggressive action reduced combat stress, while passive defense increased. It influenced military psychology and training. Modern militaries train soldiers to be aggressive and take initiative specifically because research beginning with World War II showed that aggressive action improved morale and combat effectiveness even when casualties were higher than defensive tactics would produce. The Sherman itself became legendary partially because of ramming tactics. Post-war narratives often emphasized the tank's inadequacies: weak armor, inadequate gun, tendency to burn. These criticisms were valid but incomplete. The Sherman succeeded because it was reliable, producible, maintainable, and operated by crews willing to use it aggressively. Ramming tactics symbolized that aggressive spirit, American willingness to accept costs to achieve objectives, to use equipment as tools rather than treasures, to adapt and improvise rather than adhering to rigid doctrine. Ernst Richter, whose Panther was destroyed by ramming on December 17, 1944, survived the war and later reflected on that engagement. In that moment when the Sherman hit my tank, I understood that we had already lost the war. Not because American equipment was better ours, was superior in every specification, but because American soldiers were willing to do whatever was necessary to win, regardless of cost. They would trade 2 tanks for one of ours without hesitation, knowing they could replace their losses and we could not. That calculating ruthlessness, combined with industrial capacity we couldn't match, was unbeatable. The ramming attack that destroyed my Panther demonstrated both their ruthlessness and their capacity. It was the war in microcosm. The tactic that began as desperate improvisation became systematic doctrine, then entered military history as an example of adaptation and aggressive spirit triumphing over technical disadvantage. The Sherman crews, who charged German armor at full speed, accepting casualties to achieve objectives, embodied the industrial warfare philosophy that won World War II: overwhelming production, mechanical reliability, aggressive employment, and willingness to pay costs that enemies couldn't match. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.